Hello and welcome to another tutorial. So this time we're going to be taking another look more in the realm of design patterns again, and we're talking at a bit of a higher level here in terms of composition and inheritance. So quite intentionally I'm saying composition and inheritance, not composition versus inheritance. It's not something where it's a case of you should only do one or only do the other, or where one is better than the other. Both have absolutely their uses and their places, and sometimes using a combination of both is actually going to be the best approach. So I'm very strongly opposed to sort of views where it's like, yep, there's this one right way of doing things, and it should only ever be done that way. Because that's often a load of nonsense. So we want to look at what these actually are, how we can use them, and how we decide which one is most appropriate or whether a blend is most appropriate. That's what we're going to be taking a look at. So first, let's actually look at, well, what the hell is composition and inheritance? So Unity is actually a really, really easy one for illustrating composition in, because Unity kind of lives and breathes that a lot. So the idea of composition is that we build up something from multiple parts, that there are multiple elements that we combine together to something, and that there isn't a hierarchy in those elements, they're at the same sort of level. What happens on a game object in Unity is an example of composition. So a game object has a transform component. It has, in this case, to turn it into a camera, gets a camera component and an audio listener. Whereas a light, again, being a game object, always gets a transform component, but it also then gets a light component. So what an object is determined by the sum of its parts. That's what composition is about. So we could do things like for a character in a game, we could give them a component that allows them to walk, another that allows them to fly, another that allows them to hold items. So this is what we're talking about with composition, where we have multiple elements combining together and the whole is greater than the sum of those individual parts. Whereas something like inheritance is quite different. And Unreal uses inheritance to a much higher level than Unity does. So Unreal is actually a really good example of seeing where inheritance gets used a lot. But just as in Unity you can do inheritance, in Unreal you have components and you can do composition. So what Unreal tends to do is we might have a actor class, and an actor represents something that can exist in the level and has a visual representation. But then that branches off. So you might have a static mesh actor that is geometry that, while it can move, the actual geometry itself doesn't shift. The mesh is static. But then you can also have a skeletal mesh actor, which is based off of actor, and that gives you something that has a skeleton that can move around. And you have progressive hierarchies there because you have things like a character, so something that can move around. You have, a what's called a pawn, which is something that is able to be moving around, is able to be running AI behaviors, can have perception systems. So you have quite a deep hierarchy there. But even with that, you can still attach components onto things. So you can give an AI the ability to have different sensors by giving it a perception component. So both have their places. And what it comes down to is the kind of thing that you are trying to do. So what I'm going to do first is I'm going to set up a couple of scripts and I'm going to illustrate an example for composition and a case where it might be appropriate. So I'm going to create a object here. And this I'm going to call it composition demo. So let's say I have multiple unrelated things that I want this to do. That is something where composition is an applicable scenario. So multiple independent things. Now, it doesn't mean that the combination of those things isn't actually a really useful, valid combination. It just means that they're independent. They're not interacting with each other. One doesn't need to affect the other. So I could set up a script that is a bounce effect, and I could set up one that is a rotate effect. So these are doing entirely independent things. Bounce will be causing actual translation, whereas a rotate is going to be causing it to turn. We won't worry about setting up the logic for this, but this illustrates the intent of where we would be using composition when you have independent things. Another good use case for composition is something like procedural generation, and you'll see in the procedural generation stuff I've set up, I use this approach, where I will have a stack of modifiers, and each modifier is a entirely independent script. It uses data the others generate, but it actually is operating on its own independently. So what can happen with the procedural generation is I can have a whole stack of things that modify the height, and it just goes through and runs them. So having composition is really good for when you have a scenario where you have logic, you have behaviors that need to work independent of each other. So when there is not a large amount of close coupling there. You could have some interlinking, but generally it's something where you don't have a lot of deep logic of one affecting the other, and one needing to talk to the other a large amount. However, composition might have a manager object that is talking to the attached things. So for example, we could have an effect, let's try that again, we could have an effect manager. So composition doesn't mean that you just have to have the scripts on their own, doing their own thing. We can have an effect manager, and it can be handling the actual composition logic as well. So what we could do, so composition stuff here, we could be setting up, so okay, we have a rotate effect. Rotate. And we could have then for our bounce effect. So this, still talking about composition here. The main thing we've got is, while with composition we often don't have those individual components talking to each other, we do at times have a parent object that is doing a lot of communication with them. So this could have something where we have a control here for enable effects. And we might actually set that to false, but we could then be checking here. Okay, well, if enable effects is not equal to, we'll keep the previous version. And we'll store that here. So if this is changed, then we could go and say, okay, well, rotate enabled is true, or we set it to actually to this. And we do the same with the bounce one. Bring that up here. Bring this logic one down here. So what we've got then is something where we still have these independent effects, but we actually have a manager object that is now able to be controlling them. And we run it, nothing will actually happen because we need to link these up. And then, so now what I will find is their state is going to be synced to this. So composition, still common to see a manager object that has links to particular things. That's a very normal setup that you might have. So, okay, we've seen therefore our composition process. What about then inheritance? So we're already using inheritance. It is actually something that we've already worked with. And I'll set up a script here. Inheritance demo. I'm going to then create a script. So we could have something where, okay, what if I want to have a base effect? Because there might be common properties that all effects should have. There might be common interfaces that all effects should have. And this is something that inheritance allows for and actually makes quite easy, is it allows us to say, okay, I want to make sure that here is a core set of data, functionality, both, that anything of this type actually supports. So with the effects, there might be specific things that I want all of them to have. And there might be some common logic there that all of them need to do. So in a case like of that, inheritance allows us to remove duplication of that logic. So I could set up, well, I want to have a base effect. And what I'm going to do is every effect, we might want it to have a speed. So I'm going to set up we'll make it a protected float. And I might make it that ranges from 0 to, let's allow it to go up to a fairly large speed. So once I can go from half speed up to double speed. It might also have a period, a time to it. So, okay, a protected float period. So what we can do then is, let's say everything is 2 seconds. So, okay, that's good. What we could do is then make it really easy for our effects to just get their progress through the particular effect, because the calculations here would be the exact same. So our rotating, our bouncing, they don't need to get and manage all of the stuff in terms of period and speed and time. It's something that we want it to be centrally managed. So what I could have is, and I'm making this private so that it doesn't get seen by the child classes so far. So what we can have is current time, then an update. We'll actually call that current progress. So I can make current progress, I can add time.delta time multiplied by our speed divided by period. That will give us something that is going to be between 0 and 1 generally. So we can say current progress plus equals. And what I would do is, if current progress is greater than or equal to 1, then we just want it to wrap around, which actually what I can do as an easy way of doing that. So go back to the plus here, and I can say current progress is equal to that modulus with 1. So current progress, well, be handy if our child classes could read that. So this is one of the cases where I would actually make a protected property. Because I can make it protected get, but a private set. Oops, autocomplete. Which actually I can just leave that as get. It'll take that. So now we have a property that the child classes can access. So the time is being updated. So rotate effect, I could switch this to now it inherits from base effect, which means I need to go and make some changes here. These need to become, we'll do protected virtual, just because I want these to be able to be overridden. So then these become protected override, and we'll run the base ones. So I can say base start, and then base update. What this means is I can access progress here now. So I'm able to write a lot less logic. In this case, I don't really need start, so I can just get rid of that. Now I could set up here so that then, okay, well, let's go transform, rotate. We could give it our particular axis. So let's just have it rotate around all the axes. So I can do current progress. And if I just want it to be able to do this, now that's not going to do a nice sort of looping animation, anything like of that, but it will do what we need. So this is trying to override on here. We just need to make sure we save, so it's properly overriding it. So with the inheritance one, I can add on my rotate effect. Now I haven't set up the bounce effect yet, but I'll add that in for now. And so we've got this one. We need our another cube, so I'm going to give this one a child object. Doesn't strictly need to be, but let's make it a child object. And we run this, so we can see it's happily rotating around. So that's good. And our composition one, we would also find with this, if we then turn on the rotate effect, it also rotates. Or we can turn it off. So we've got that working. We'll set up so that our bounce effect is also inheriting off of that. So we have protected override, and we run base update. Don't really need start, so we can get rid of that. And again, we could be doing things where, okay, we could be storing the position and offsetting based upon that. So I could have initial position. Actually, that would be a case where then we would do a protected override or start, initial position. Let's transform that. But if we found we had a lot of effects that were needing to cache that initial position, we could do that in the base effect. So I could easily bring that over here, make that something that is protected, and again, make it that it is only privately settable, and store it there, which again simplifies our logic here in any effect that needs that. So we gain a lot from inheritance in terms of removing duplicate code. We write the same code less often, which is incredibly valuable. The less we're having to write in terms of code, the better. Less code means less potential, surface area for having bugs and errors. So it's always a good thing to have as little code as possible. Makes it easier to debug. It's a win on all accounts. So inheritance allows us to, when we have objects that already have a logical relationship where there is a similarity in the behavior between them and where there is a natural hierarchy. So, for example, you could have a base class for all of your AI, but then you could have one for animals, one for humanoids, one for vehicles, and then specializations within that. And that allows you to have it that for all of the vehicles, there's probably common logic there. and you only need to specialize the bits that you have to. So it removes a lot of duplication. So inheritance is incredibly valuable for saving time for things like that. And we need to fix up that. So inheritance is very, very valuable for saving time on that. So, okay, we've got composition when we've got unrelated components. We have inheritance when we have things that are actually very related, and where we might want to override or enhance the behavior of one class in another. So that's the big sort of separation between them. Composition, a lot of independence. Inheritance, very direct dependencies. Combining them, because there is a lot of value in combining them. So I'm going to create this time let's go for a capsule this time. I'm going to move it up. This is going to be composition plus inheritance demo. So this is going to get our bounce effect and our rotate effect. Now, when we were working in the composition one, to have a manager thing that was working with these, we were just going and manually linking in the particular ones. We had the very specific variable types there, which is not great. You can imagine if you started to need to add in a lot of extra effects, that gets particularly messy. So that's why just composition on its own isn't the solution. So composition's not the solution there. Inheritance, well, we can't create one uber effect that actually has, every single thing in there. That would be, firstly, is just not possible in the language, which is a good thing because that would be an absolute nightmare. But we can actually make use of the fact that we've got inheritance to do the composition better. So the synergy of the two works really, really well. So what I can do is I'm going to set up a script. I'm going to call this Better Effect Manager. And this is the one that I'll use on here, because the fact that we're using inheritance actually allows us to do the composition side better. And this is a common scenario of how I use this. So with the other one, I was having to link stuff up in the inspector. I don't want to have to do that. I want to be able to have a list of base effects. We'll fix up the name there of that. So I have my list of base effects, and in start, well, I can go get components, base effect, and I can say effects is that. I'll need to wrap this around it. Populate it into the list, but I could also change this to being an array, would be perfectly valid. A list is handy if I want to be removing things from it potentially. So I can do that. Well, what was the other stuff I had here? I had this logic, so I'm going to bring this logic over. But it's going to be a lot simpler for doing everything. So I'm just going to bring this over as well. So the idea is I want to keep it as close to the other one as possible. But now, for enabling and turning off ones as well, I can just go for each, var effect and effects, effect dot enabled, is this. And then I can do the same here. And again, store, I'll update the previous one. So by using composition and inheritance, my effect manager, I can now add in additional effects, and this code doesn't need to be changed. Whereas with using composition alone and doing nothing where I'm using any inheritance, every time I need to add in a new type of effect, I would need to modify this. And that's not ideal. That's actually means I'm adding in firstly, potential for mistakes, but also I'm adding in maintenance overhead, which I really want to try and avoid doing. So using this mixture of inheritance and composition makes our lives a lot easier. And we can see we'll still be able to get the same effect. So it still works exactly the same. Performance is going to be similar. The main difference is we've made our lives easier. Maintenance is significantly less, which is good. The potential for mistakes is significantly less, which is also good. So I strongly recommend diving into both composition and inheritance. They are things that are absolutely game changers in terms of your processes, the development time, the development effort required. They make a huge impact and a hugely beneficial impact. So do make use of them. But avoid the mistake of thinking, nope, it has to only be composition or only inheritance. It's not the case. They have their purposes and they have scenarios where one might be more beneficial or more straightforward than the other, but they also have a bunch of scenarios where a mix of both can actually be incredibly useful. So going back to the procedural generation, the stack of modifiers for the height, those were all different classes, but they had a common base, which meant that I was able to add in new types of things without modifying the majority of the code. I just wrote that type and the rest worked. That's the advantage we get from using a combination of both of them. So think about how you want to be structuring stuff is how I'd look at deciding things. If there is a high level of independence between the things, then composition is more what you're looking at. If there is a very clear dependency, if there is common logic, common data, then inheritance is likely going to be more what you're after there. You don't need to go super deep with inheritance hierarchies. As I said, using a combination of both can be really handy. So you do look at using a mix of both often. You'll find that is usually the way a lot of things will end up going. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and I've placed a link to that in the description below. There is also a link in the description to the video archive, which is a searchable archive of all of the videos. So you can look through different ones if you're trying to find a particular thing. If you have any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.